Okay, we finally come to today's webinar, which is given by Nicolas Antunes. He has studied biology and ecology, but also did several postdocs in anthropology. And now he is a programmer at the German Archaeological Institute, which is also one of our partner institutions. And the topic for today is R as mini GIS, build interactive maps from scratch.
We will build a dynamic map and we will put it in a Shiny app. So when we deal with map, a good package to have is just maps. So you can install this package with the command install packages and load with the command library. Maps allows you to just have a map of the world, and you can, of course, you have several options, and you can choose to plot one country or a selection of countries, etc. We will use it later to see where we are on the map. This presentation will be in two parts. The first part, we will deal with the data, we will combine them, we will transform them, and we will have raw maps. And in the second part, we will integrate these computations, geographical data into dynamic maps. So first, we need data. So for that, we can load the package geodata, which is a package that have climate data, such as temperature, minimum temperature, maximum temperature, etc. So for instance, if I use this function, world clean country, I can download the maximum temperature for Germany. Here is the maximum temperature, and I decide to put in the temporary directory. So here we just downloaded the Tmax, the temperature max Tmax temperature for Germany, and we can see that is a SPAT raster, so it's a spatial raster. And here we have the characteristic of this file. So here is resolution. You can see that he has 12 layers, and it's a raster with 1,000 row by 1,200 columns. Here you have its extent. We will see later what is an extent. Here you can see that here this file has a georeferencing system that is the WGS 84. The source of the file, and you add the names of each layer and their minimum and maximum value. There are 12 layers because if I plot it, you will see 12 different maps there, and each map corresponds to 1 month. So for instance, if I want the temperature max for January in Germany, I can do this line. So I ask for the first layer of this file, and I have this map. And I can add also the border with the map function. So we can do exactly the same for France, for Italy, and then we can look the result. So this is the result for France and the result for Italy. So now we have some data, okay. What we can do is to do some calculation on that. For instance, we can calculate the average of the temperature max for Germany. And here I have the result there. And we can also merge different raster together. So here I will merge the temperature max for January for Italy, Germany, and France. So here you have your merged raster. But I can also do that on the stack of the raster, and it will do that for every single month in the raster. So you see, you can combine different layers to have the data you want to get. And let's try to calculate the summer temperature maximum for this area. So here we do the average between the month 7, 8, and 9. So July, August, and September. So we are our summer Tmax raster there. So now we will continue this with another set of data, like we did last week. We will use the Penguin package of Palmer. I voluntarily put them in Europe. Like this, we are more familiar with the area than the Antarctic, and it's easier to follow. But of course, penguins can't live in Europe. But we will try to teleport them in the Alps because I think it's cold enough. But of course, it's not in the sea, and they can survive. So let's say for the penguin survival, they should have a maximum temperature for the warmest days of the year of 17 degrees in average maximum. So we call it the critical temperature. So now we can calculate this survival area. So we take our raster and we just look where this raster is below the critical temperature. And we can plot this raster. So here you see you have a raster of true false. So the yellow is true and the purple is false. And that means in the yellow part, our temperature is below the critical temperature. So for the following, we need the package raster. And we will try to define an area where we can teleport our penguins. So we can see here, this area is between the latitude, the longitude 5 and 15, and 44, 48 approximately. So we define with the package raster an extent that we call target area extent. And we can plot this extent. Here you see it's this white rectangle. So now we will load our penguins data with the Palmer penguins package. And we will affect randomly their coordinates. So for that, we create two columns in the penguins data frame, a column longitude and a column latitude, where we randomly take coordinates that, for instance, for the longitude, that are between the minimum longitude and the maximum longitude. So to call an attribute of an extent, so here you can look the extent here. It's a S4 object. So to call an attribute of S4 object, we use the @ sign. So here, if I have target area extent at xmin, I will have the minimum longitude. So I construct my columns, and now you can see the data frame penguins have two columns, longitude and latitude. and we can plot it on the map. So here I use the function points, but you can also use the function plot, of course. So you see our teleportation works well, but not so well, because actually we teleport a lot of penguins out of the survival zone. So poor penguins, they will probably not survive, even if we set it to 70 degrees. Okay, so now we can try to define which penguins have been dropped in the survival zone. So for that, we need the library SF. SF is the abbreviation of simple features. And we can also use this library, which is very useful to deal with data frame. So with this function, st as SF, we will transform our penguins data frame into a SF data frame, SF object. So now you can see that's also a data frame, but it has too big. Oh, yes. So it has geometry type. So you see that it's a point file. And he has an extent. He has also a geographical system. And you have this column there that appears geometry. That is the coordinates. Okay. So now we have this object. We can use the function extract from the package raster to see which are the penguins from this SF object that are in the survival area. So here we have, you see these penguins in survival zone give us a data frame with false, 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 true, NA, and so on. So you have false value when it's not in the survival area and a true value when it's in the survival area, but you have also some NA value. And that is due to the fact that there are presence of NA in the raster. If I do this function, you can say that it's true that there is NA in the survival raster. So that means there are points that they have no temperature. So now what I will do is in my penguins SF data frame, I will SF data frame, I will add a column survival zone where I will put this true false data. So here is the column that I had. And if I look inside the SF data frame, I have to extend it to show you. No, sorry. Yes, survival zone, and you see false, 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 NA. That's okay, but we have some NA. Let's see where are these penguins with no temperature value. So for that, I filter and I just take the data, the row where there is NA in the survival column. And if I plot them now, so I plot the survival area, and now I plot the penguin, and we see that they follow into the sea. Okay, so in any case, their temperature will be more than 70 degrees for the max temperature. So to calculate the number of penguins that follow that have been dropped in the survival area, these penguins in the sea are not important. So we can just count in this column the number of true. And for that, we just omit the NA and we do the sum of the color. And we have 74 penguins. So it's not so much. There is more than 300 penguins in the data frame, so we didn't save a lot of penguins. Okay, so now you have seen how to deal with data. You can do much more, of course. You can do a lot of extraction. You can combine layers and extract information. Everything you can dream of. So now let's see how to generate a dynamical map. So an easy way, very fast, but not very easy to customize, is to use the library MapView. So here, if I just apply the function MapView on my penguins SF data frame, you can see that I will try to make it a little bit bigger. So we generate a map with all our penguins, and we can even change the background of the map, or decide to plot or not our penguins. There are many options. We can, for instance, here, I can define that I want one color for each species of penguins by using this Z call and call the column species. So, and here you see that one color corresponds to one penguin, one penguin species. You can store this into a variable. So here you have your map that is stored. And if you want to record it, you just have to make a map shot, use the map shot function, and indicate a URL. So basically, a path on your computer. So here I will generate the file map1 HTML, and then you can and then you can browse. When you have this, you can share this file with some colleagues and so on, or put on a website. And of course, you can see into a browser. It's of course the browser appear in the other page. Do you see the browser there?
Yes, yes, we do.
Okay, perfect. So yeah, so okay. So that's a very fast way to make a dynamic map. But if you want to put your map in a Shiny app, and if you want to have more control about the layers, and to make a more customized map, you should use the package Leaflet. It does basically the same, but you control everything at every single steps. So let me show you how it works. So the package Leaflet has the function Leaflet. So if you run this function, you just got something empty, a leaflet empty. Then with the pipe operator, you will add some object to this leaflet object. So here we decide to add some tiles. So if you run that, you have a map. Now you can add some markers. So here I took randomly this longitude and this latitude, and I will put a marker on the map at this location. And of course, we don't know where it is. Okay. So you see that it's somewhere here. You can also here add a vector It's not my keyboard. Okay, so here you can add a vector instead of to add a single point. And it's what we will do later with our penguins. So now we will plot the penguins. So first we have to define a palette. So we use this function color factor to define a palette. And I took the same color than last time for each species. And you say that the palette is applied on the penguin species. So once you define your palette, you can do your leaflet, you add the tiles, and let's say we want some marker, but this time we want marker as circles. So you need the coordinates. So you will find it into this data, into this SF object. And here are some attributes. How you want the points. I want the points that follow, that are filled with the color of the species. I want they are a little bit transparent, their size, etc. And here you can add for each point a pop-up where you can decide to plot some information about the point. You use the paste function that makes basically, I can't execute it. A vector, and it's mostly some HTML. It looks like very much HTML, and you will use for your pop-up. Just retain that here you have the variable that you want to plot, and here the text that you want to put front. And you can also have an attribute label that is for when you over the point, you will have something that will appear. And here it will be the data if the penguin is in survival zone or not. So now if I run this code, so I have my penguins, so each color for each species. And when I over them, I see that they are in the survival zone or not. And if I click on them, I have some information. Here I choose to have the bill length or the bill depth and the species. So, okay, time is good. So now we can continue to add some control layers. So if you remember in the map view, here you had a menu and you could select the background. So to find some background, you have to go in this website, but you can go anywhere, but here you have a good selection of websites of background. And here you have a huge list of background that you can choose. So what you have to do if you want to add a map, let's say, I don't know, something nice. But maybe it's fine. So you just take this name there. So you copy it. And you add as a provider tile. So here I had this one I found, but I also had some other. So here you have to also to give you a name. So you put it into a group. So let's say this one is SV. And so you see here, I download some other. one for the relief, one for the map with the German names, and one that is called topo. And then after, I can also add a raster. So here I had, for instance, the survival area raster, and I set it to the group survival area. And I also here define some colors, and I said what is false, it's transparent, or NA is transparent, and what is true will be blue. So the raster would appear in blue on the map. So when I added these tiles, I have to make the menu to be able to select them. So for that, I use these functions add layer control, and I list into base group the group I want to put in this menu. So the relief, the OSM, the topo, the survival area, and I can add the S3 group. It's the one I just had now. And I don't forget the comma. So now I will try to plot this map. Voila. It was a little bit long, I don't know why. So here you see that we have the file that we provided here, and we can change them here in this menu. And if you want to see the survival area, you see it appears there in blue. And all the other features, of course, are still working. So now what we can do is also create some layers from our data. Namely, what we will do is we will create a layer per species. Like this, we will be able to select to display only the penguin of the added species or the other species. So for that, I also use the leaflets. I had the tiles, of course. I add the circles marker, my provider tiles, and my control layers. But there is a difference now here. I say okay, the group of the penguins, the add circle marker, will belong to the group penguins. And in my add control layer, I will add another category that allows me to have now not a checkbox, but a radio button. No, sorry. That another category that allows me to add layer over the other layers, and we call it overlayer groups. And we put the penguins group that is corresponding to our circle markers. So if I do now that, you can see here we have our penguins, and here, so we have a checkbox now this time. Before we had a radio button, now we have a checkbox, and we can see that we can put decide to plot our penguins or not. But you can go a little bit further, and instead of to put the group penguins, you decide, you say the group of this marker circle will be the species name of the data. So for doing that, you use this tilde symbols and the name of the column you want to use. And of course, you have to change it also in your control. So here I remove this, and I will put here, I use the function unique that will list only one time the species, and so like this, I will say, okay, the overlay group will be the group allele, the group Gen2, and the group Shinstrap. So now, if you run this line, normally it's a little bit faster, but it's due to Zoom. And here you can see that you have checkbox, and you can decide to plot your penguin or not. Okay. For the rest, I will store all this map into an object M. I did it like this. Now I can add things to M with the pipe operator. For instance, I can add a legend and to plot it, and I say the new M is the M plus the legend. And to plot it, of course, I have to run M. And here you see I have the legend. In my legend, I decided to put it on the bottom left, and the color of the species and their value. You can also, can be useful, add a minimap with the function add minimap. And here you have a minimap that appears. That could be very useful because sometimes you don't know where you are. And you see directly in the minimap where you are. You can add a rectangle. For instance, here I will plot the rectangle, the area. So of course you can set the color of the rectangle and so on. And you can also define there by putting directly the coordinates. And you have also some tools like measure tools. And here you see you can create a new measure, and you can go somewhere and decide, okay, let's see what is the area of this lake, roughly. I let you do the conversion, but of course you can set in kilometers and so on. So I tell you in the abstract that you can also add some shapefiles. So here I will show you how to add one shapefile, and this shapefile is corresponding to the glaciated areas in the world. I got this, I download this shapefile here, then I extract the folder. And for that, I will use the library SF that we already loaded, and the function stread. And you just have to put the path of your shapefile. It's important to, you can put, I think, any file from the folder, but it's important to keep all the files that are in the folder that you just download. So here you can load the shapefile. And to, of course, it doesn't work. Doesn't seem to exist. Yeah. I should download it again. Wow. Okay, let's download it. Oh, loading. Is there? Okay, was there? Maybe I have a problem with my address. Okay.
Does it maybe depend on the session environment? Should you move the folder?
Yeah, I am not in a good place, I think, yes. You will see everything of my my folders. Okay. Okay, found it. Um, up, so now it should work, I hope. Okay, so you see, I I didn't indicate it the good path. Sometimes it happens. And now I use the function add polygons, and I can add the polygon to the map. Of course, the extent will be bigger, so we will have all the glaciated areas in the world, and we can have a look. Maybe if our penguins fall inside, not so much. Huh? Yes, there is one maybe that is the key. Okay. So now, if you want to build a Shiny app, so you have just to add this leaflet output in the UE side, and in the server side, the render leaflet, and then you can set you can do your Shiny app like that. So what I did is, and what you probably saved and maybe use, is an app. So I just do 2 columns in the UE side, and in the server side, I do all my computation that we did before, and after here, I'm rendering the map. So I just have to run this app. So it will take just a little bit of time because it computes all the raster, it download them and compute them. And you can, of course, have it into a browser. It's a little bit long, I'm sorry. Of course, you can make it much faster if you have download the if you have downloaded all the raster and all the data before, like this, it doesn't have to do the computation. Normally, it's much more faster.
We have somebody with a raised hand. Julian, do you wanna?
Yeah, I just wanted to add that we add penguins in Europe, but
yes,
we brutally killed millions of them, and they are not extinct. So there used to be penguins in Italy and France and across the Atlantic coast.
Yes, there are some penguins that are drawn in some caves.
So penguins, the name was the great oak in English. They're extinct.
So the R was too busy, so I had to rerun it. So yeah, I think it takes too much memory because I put a lot of information inside, but normally it's more robust. So here you see that is downloading the file. So, okay, so you have an app. I don't know if some of you have downloaded the file and tried to run the app. And the idea, this is the app. So you can see here, you can do the measure and so on. And here I changed the units. So now the idea at the end of the workshop was to make a little hands-on and try to save these penguins that can survive there in this environment and re-teleport them into Antarctica.
Just a quick moment, we have a question in the chat. Rebecca is saying that when she tries to add the legend, she keeps getting an error saying that the object M is not found.
Yeah, it's commented out. You just need to remove the sharp.
The hashtag.
Yeah, hashtag. Just
Yeah.
remove the hashtag from the line above the previous leaflets.
Yeah, basically. So if the M is purple, it means that you're not really running that line of code. Yeah, perfect. All right, then we can move on.
Thank you. Okay, so if you want to, we can try to do this hands-on together. So the idea is to put back our penguins into Antarctica. Someone has an idea how to do it? Okay. Yeah, maybe it's too brutal. So here I give you some hints. So there is the Wikipedia of the Palmer Archipelago. Like this, we can see the location where it is. If we look that often in Wikipedia, you have the page for the coordinates, and here you can see the decimal coordinates. So we have approximately -64 and -62 as coordinates. So we could download the data we are interested for with the geocode, but this download will take too much time, so we will not do that, especially with the Zoom. So we will download the Tmax data with this function of the geo package, of the package that allows us to download the tile according to a longitude and a latitude. And so it will take a little bit of time as well. Then after,
maybe while that runs, I can read a guess that came from the chat. So Lisa asks if we change the target area to Antarctica using coordinates and then that we teleport the penguins.
yes, that's
Yes.
a solution.
Perfect. Good job.
Solution.
Spoiler. Oops.
No, that's very good. Thank you, because I didn't open the chat, so
No problem.
Couldn't see it. Yes, effectively, you have to change the extent, and then after you affect them with their coordinates. So here, I download this the tile. I define that my summer max temperature are there, and here I have the extent, and I will take the extent of the summer Tmax raster that I calculated there. Or even better, more accurate, I can put an extent directly with these coordinates. So let's put that into the app. So here, where I calculate the Tmax raster, I will just overwrite on it. Maybe I can, yeah, no, let's that. And summer Tmax raster will take this Tmax that I calculate here. And we will change the extent. Here, target area extent, I will overwrite and put this extent instead of this extent. I can comment this time. And I run the app. So it will take time again. And yeah, this is the solution. Maybe if the time it downloads the app, I can answer to some questions. That was faster. So here our penguin are safe again and back to their home.